prism. We are not talking about pyramids, prism. In your high school studies, you have seen dispersion of light through prism. Now, same thing, dispersion of light through prism, refraction of light through prism with equations. There is a 5-mark derivation. Expression for refractive index given by n equal to sin A plus capital D by 2 by sin A by 2. Angle of the prism, minimum deviation. So I use capital D. Sometimes people may use delta m, capital D m, small d m. So be flexible with notations. So whichever notation you use, you just mention once and then proceed. Refraction through a prism for a monochromatic ray. Monochromatic light, monochromatic ray. Monochrome means single wavelength. It is a hypothetical concept. Single wavelength is called monochromatic. In reality, it is very difficult to get monochromatic light. Okay. Now, let us draw and understand refraction through a prism. Students, you have to copy these diagrams, use scale, pencil and draw neatly. This is base of the prism. Two refracting faces. This is base. Base is shaded properly. Let this be an incident ray. So this is incident monochromatic light. To draw refracted ray, let me draw normal first. So this is normal drawn at the point of incidence. Light ray is going from rarer medium to denser medium. If this is glass and air outside, rarer medium to denser medium means the light ray bends towards the normal. So this is the refracted ray. Now, to draw emergent ray, again I should draw the normal. So this is the normal drawn at the point of incidence. Now, this light ray is traveling from denser medium to rarer medium. So it should bend away. So this is how refraction through prism takes place for a monochromatic light. Okay. In this interface AB, light ray is traveling from rarer medium to denser medium. Draw normal. Incident ray. This ray, when it enters the denser medium, it should bend towards the normal. This is I, this is R, this is the direction of incidence. In this direction, light should supposed to travel, and this bending, this angle is deviation, denoted by D, and deviation is given by I minus R. This total angle is I, vertically opposite angles. So deviation is I minus R. In this case, if this angle is I1, this angle is R1, then deviation in the first interface, deviation in interface AB is I1 minus R1. I minus R, in this case I1 minus R1. Now, second case, denser medium, rarer medium. Normal drawn at the point of incidence. This is the incident ray. Light ray is traveling from denser to rarer, therefore it bends away from the normal. This is angle of incidence, angle of refraction. If I continue this is the direction of incidence. This angle is equal to this angle, vertically opposite angles, angle of incidence, angle of incidence. This is the deviation. So when light ray travels from denser medium to rarer medium, the light ray bends away from the normal. As a result, deviation is given by r minus I. Deviation is r minus I. So in this case, light is traveling from denser to rarer. So the light ray is bending away from the normal. It should travel straight, but it is bending away. Okay. This is the refracted ray or emergent ray. If this small angle is R2 and this angle is I2, then deviation at the second interface, refraction, angle of refraction minus angle of incidence. Angle of refraction is I2. In this interface, angle of incidence is taken as R2. Therefore, R2. So deviation is I1 minus R1. Here deviation is I2 minus R2. Angle of refraction minus angle of incidence. Students observe, angle of incidence is taken with R2. Angle of refraction is taken with I2. That is why I2 minus R2. Angle of refraction minus angle of incidence. Angle of refraction minus angle of incidence. This is how refraction takes place through a prism for a monochromatic light. Now, refraction through a prism for polychromatic light. Polychromatic means many wavelengths. So, refraction through a prism for white light also comes under polychromatic. Let us go through refraction using ray diagram. For polychromatic light. Base of the prism, refracting faces. This is incident polychromatic light like white, normal drawn at the point of incidence, normal. So this light beam undergoes refraction. They undergo refraction, at the same time they undergo dispersion. Dispersion means separation according to some parameter. So dispersion of light means the arrangement of light according to wavelength or frequency. But this angle is very small. This angle is called angle of dispersion. So with only one refracting phase, there is dispersion as well as refraction. Dispersion and refraction. But the angle of dispersion is not sufficient. That is why second interface is used, second refracting surface is used. Now, this light ray again traveling from denser to rarer, therefore instead of traveling straight, this bends. This extreme ray also bends. Now observe, this angle is greater than this angle. So angle of dispersion can be increased by using second refracting phase. AB is a refracting phase, AC is second refracting phase, and BC is the base. This is called spectrum. This is spectrum of light. Spectrum of light means arrangement of light according to some parameter. Arrangement of light according to wavelength or frequency. So here this is violet and this is red, and all other wavelengths between violet and red will be in between these two extremes. Okay. V, I, B, G, Y, O, R, and this extreme is red, this is violet. So this is the incident ray, right? Let me draw direction of incidence. This is the direction of incidence. Students, make sure that you draw this, you extend this incident. So light traveling in this direction in the absence of prism should travel straight. So this is called direction of incidence. Now with respect to direction of incidence, this angle is the angle of deviation or deviation for red. This angle is deviation for violet. Violet, direction of incidence, deviation for violet. And if you carefully observe, this angle is the difference of these two. So angle of dispersion. Angle of dispersion theta equal to deviation for violet minus deviation for red. Deviation for violet minus deviation for red. This is theta. This theta is this angle of dispersion. So for 1 mark questions, which is most deviated or which color is most deviated when white light passes through a prism? So answer is violet. Violet is most deviated. The other question, which is least deviated when white light passes through a prism, means it is the red which is least deviated. What is the expression for angle of dispersion? Expression for angle of dispersion is deviation for violet minus deviation for red. If deviation for violet is 35 degree and deviation for red is 25 degree, then angle of dispersion is 10 degree. Am I right? So in this 10 degree, we can find all other wavelengths separated, because this is spectrum of light. Spectrum of light means arrangement of light according to wavelength or frequency. So which wavelength is most deviated means violet is shorter wavelength. So shorter wavelength is most deviated. Longer wavelength is least deviated. Violet is most, red is least. Shorter wavelength is most, red is, longer wavelength is least deviated. Okay. Let us derive an expression for refractive index of the material of the prism in terms of other known parameters. Now let us derive an expression for refractive index of the material of a prism in terms of known parameters. Or the question could be, derive n equal to sin a plus d by 2 by sin a by 2. Base of the prism, refracting phases. AB is a refracting phase, AC is another refracting phase, BC is the base. Let this be the incident ray. Incident monochromatic light. Then let me draw refracted ray parallel to the base. This parallel to base. You will understand why it should be parallel to base, okay, for time being. Next, emergent ray. Incident ray, refracted ray, emergent ray. So PQ is the incident ray, QR is the refracted ray, RS is the emergent ray. Let me draw normals. Normal means perpendicular drawn at the point of incidence. So this is normal drawn at this point of incidence. This is normal drawn at this point. If you draw carefully, then these two normals will meet at this point, which is just below this A. If the diagram is correct, means you will get this point below A. Fine. This is the angle between incident ray and the normal. So let me call this I1, angle of incidence. This is angle of refraction. R1 is angle of refraction. This is angle of incidence in the second phase. This is angle of emergence, I2. PQRS is the path of light. Let this be T. This point is T. So let me write a statement for ABC. Students, what is ABC? ABC is principal section of a prism, where AB and AC are refracting faces and BC is the base. Consider a prism of refractive index N. Let AB and AC be the refracting faces and BC be the base. AB and AC refracting faces, BC is the base. Let PQRS be the path of light. PQRS be the path of light. MT is the normal drawn at this point. NT is the normal drawn at this point. Let I1 and R1 be the angle of incidence and angle of refraction at the interface AB. Let R2 and I2 be the angle of incidence and angle of refraction, angle of emergence at AC. Students, copy these steps and the diagram. Let the diagram be little bigger. Okay. Here the light ray is traveling from rarer medium to denser. Therefore, the light ray bends towards the normal. So, deviation at AB is D1 equal to I1 minus R1, angle of incidence minus angle of refraction. Here deviation is angle of refraction minus angle of incidence, I2 minus R2. Therefore, net deviation is D equal to D1 plus D2. Net deviation. This light ray bends clockwise. Again, instead of traveling straight, it bends clockwise. From here, deviation is D1. From here, deviation is D2. So, what is the net deviation means? It is D1 plus D2. Why it should be D1 plus D2 means both the deviations are in the same sense, clockwise or anti-clockwise. So, in this case, both of them are in clockwise sense. That is why total deviation is D1 plus D2. And what is D1? D1 is I1 minus R1 plus D2 is I2 minus R2 equal to total deviation I1 plus I2 minus, take minus common factor, R1 plus R2, use bracket, R1 plus R2. This is the total deviation D, equation 1. Now, consider this quadrilateral QART. This angle is 90. This angle is 90. So, opposite angles is equal to 180 degree means it becomes a cyclic quadrilateral. Sum of 4 interior angles is 360. These two are 180. Therefore, sum of these two should be 180 degree. Correct. Therefore, in cyclic quadrilateral QART, sum of these two should be equal to 180. So, angle A plus angle T equal to 180 degree or simply A. Okay. In triangle QRT, sum of 3 interior angles of a triangle is 180 degree. So, R1 plus R2 plus T. This is 180, this is 180. So, in place of 180, I can write A plus T. A plus T is 180, A plus T. So, T get cancels. A equal to R1 plus R2 implies angle A equal to R1 plus R2. Now come to this R1 plus R2. If this is A, then expression for deviation becomes I1 plus I2 minus A. A equal to R1 plus R2. In equation 1 gives deviation equal to I1 plus I2 minus A. Let this be equation 2 and this be equation 3. As the angle of incidence increases, the deviation first decreases and then increases. That is the nature of this equation. Y-axis deviation, x-axis angle of incidence. So, nature of the equation says, as the angle of incidence increases, the deviation first decreases and then increases. It goes like this. So, if you consider any deviation, that deviation can be obtained at two angles. This is I1 and I2. See, for I1 and I2, for two angles, we get the same deviation, which is not appropriate. So, when deviation decreases, observe this separation between I1 and I2. I1 approaches I2. I1 approaches I2 as the deviation decreases. And at some deviation, D denoted by capital D, which is called minimum deviation, I1 will be equal to I2. See, these two are I1, I2. If deviation decreases, I1, I2 approach each other. If deviation further decreases and reaches this point, there I1 is equal to I2. Let it be equal to I. So, I1 equal to I2 equal to I only at this deviation called minimum deviation position or minimum deviation. At minimum deviation, I1 equal to I2 equal to I. I1 equal to I2 equal to I. Observe, if I1 equal to I2, these two angles are equal, then these two angles must be equal. This implies that R1 equal to R2 equal to R. If these two angles are equal, then the diagram is symmetric about this vertical axis. If diagram is symmetric about this vertical axis, then naturally, to maintain symmetry, this refracted ray should be parallel to the base. That is why in the beginning we have taken this parallel to base. Okay. I hope you understood why this is parallel to base. Now let us substitute I1 equal to I2 equal to I and this in equation 2 and equation 3. Equation 2 becomes A equal to R1 plus R2. A equal to R1 plus R2. R plus R. Or R equal to, this is 2R. So R equal to A by 2. And equation 3 becomes small d is replaced by capital D equal to I plus I minus A or 2I minus A, or I equal to, take A to the other side, it becomes A plus D by this 2. So we have expression for angle of incidence, we have expression for angle of refraction. From Snell's law, refractive index equal to sin I by sin R, or n equal to, please write like this, students, give attention, n equal to, first draw this, and in the numerator sin I is A plus D by 2, A plus D by 2, put bracket. Then in the denominator sin R is A by 2, it is sin of A by 2. So this is the expression for refractive index of the material of the prism, refractive index of the material of the prism in terms of angle of the prism A. So this is the angle of the prism. D, the minimum deviation, angle of the prism. So question could be like this: derive an expression for refractive index in terms of minimum deviation, or they may directly ask, derive an expression for refractive index equal to sin A plus D by 2 by sin A by 2. Okay, this is for 5 marks. Note: for a thin prism, thin prism means if angle of the prism is very small, if this is A, angle of the prism, if A is say less than 10 degree, about 10 degree or less than 10 degree, okay, we can treat that as a thin prism. And for a thin prism, deviation is n minus 1 into A. Refractive index of the material of the prism, A is angle of the prism. This statement is there in your NCERT book. Please note, this is for 1 mark. Second, if A is 6 degree and refractive index of the material of the prism is 1.5, then deviation is, see, angle of the prism is less than 10 degree. So you can treat this as a thin prism. If it's a thin prism, then refractive index is, if it's a thin prism, then deviation is n minus 1 into A. That is 1.5 minus 1 into angle of the prism is 6 degree. So this is 0.5 into 6 is 3 degree. This deviation is 3 degree. And what is the meaning of this means? If I consider a thin prism and this is the incident ray, direction of incidence, this angle is 6 degree. This angle is 6 degree according to this problem. Okay. Then you can find a refracted ray at an angle of 3 degree. At an angle of 3 degree. So instead of traveling straight, there is a bend of 3 degree. And this bending should always be towards the base, provided refractive index of the prism is greater than refractive index of the outside medium. If it's a denser medium, the ray should bend towards the base. So this is the refracted ray. So this is how we can use expression for deviation. Observe, deviation equal to n minus 1 into A. Deviation, refractive index. Violet is most deviated, isn't it? So deviation for violet greater than deviation for red implies that refractive index of the material of the prism for violet should be greater than refractive index of the material of the prism for red. Please follow, observe carefully. This is refractive index of the material of the prism for violet. So refractive index changes from wavelength to wavelength, and for violet it is more, for red it is less. So this is greater than this. So for that reason we can see this observation. This is incident light, there is dispersion, again there is dispersion, direction of incidence. This angle is deviation for violet, this angle is deviation for red, this is violet and this is red. So deviation for violet greater than deviation for red, this angle is greater than this, because refractive index of the material of the prism for violet is greater than refractive index of the material of the prism for red. In the next video, let us concentrate on problems on prism. Okay.